So now let's suppose that we have a total of 40 scout bees, and these 40 scout bees will go to 40 different sites in search of food. According to the quality of food found, we then select the 10 best sites, or in terms of our algorithm, we can say that each site represents a potential solution, and we select among these solutions the 10 best solution according to the cost given by them. So the sites which gives the 10 best costs will be selected, and among those 10 selected sites we further select 4 best sites as elite site, and the remaining 6 sites will be non-elite site. Now in the next iteration we will send 20 bees to each of the elite sites and 15 bees to each of the non-elite sites. That is, we have 4 elite sites, so 20 bees will be sent to each of the 4 sites, and 15 bees will be sent to each of the 6 non-elite sites. And throughout the algorithm, as we proceed through the iterations, we will keep on finding the best 10 sites after every iteration and update the sites accordingly. So once selected, these elite and non-elite sites are not the same throughout the algorithm. We will continuously update them whenever we find a better site with a better cost. Now let us look at it in a little bit more detail. So now let's say that the bees that went to 40 different sites came with the following cost values. Now, since our algorithm is for the minimization of objective function, so the best cost would be the least cost. That is, the lower the cost, the better is the site. So these are the 10 sites that we selected, which are encircled, and among those the 4 best sites are selected as elite site. As you can see here, the cost value of 9.88 is the least among all these sites, so it is the best site. This is the first elite site. Then the second elite site is with the cost value of 10.42, then next 11.69, and then 12.23. So these are the 4 elite sites, and then going further, 12.43, and then 12.75, 15.26, 16.86, 13.29, and then 17.32. These 6 sites make up the other non-elite selected sites. So these are the 10 best sites. Now each of these 4 sites, which are elite sites, to each of these 4 sites we will send 20 bees each, and to each of the non-selected, in fact non-elite selected sites, we will send 15 bees each. Remember that the total population will be 40 only. That is the number of scout bees. The total population after the end of each iteration will be considered as 40 only, of which 10 would be the elite selected and non-elite selected sites, and the remaining 30 would be the bees sent to other different random locations. Now let us go in further detail of this to see what happens in the next iteration, because at the start of the algorithm we sent the scout bees. They came with the cost values, then we selected the best 10 sites, out of which we selected the best 4 elite sites and the other 6 non-elite sites. Now let us see what happens when we have selected the elite and non-elite sites. So these were the 4 sites E1, E2, E3, and these were the 6 non-elite sites. These 4 and 6 made up the selected sites, and here is written the cost of each of these sites. Now to each of the E1 site we have sent 20 bees. These E1, E2, E3 up till E20, these all represent 20 bees sent to the site E1. Similarly, these 20 bees are sent to site E2 and so on. And for each of the non-elite site, 15 bees are sent to each site. 15 to this M1, 15 to this M2, 15 to this M3, and so on. Now, among these 20 bees for site E1, among these 20 bees, we select the best bee among these 20. Similarly, for site E2, we select the best bee among these 20. Let's say that the E8 has the best cost. So this will be selected. Let's say that E8 has best cost. Let's say that of the 20 bees sent to site E1, E8 has the best cost. So this would be B1. Let's say that of the 20 bees sent to site E1, E8 has the best cost. So this would be the best bee from site E1. Similarly, let's say that for site 2, E2 has got the best cost. So this would be the best bee from site E2. Similarly, let's say E5 has got the best cost of all the bees sent to site E3. So this would be the best bee for site E3 and so on. Similarly, let's say for site M1, let's say M7 has got the best cost among these 15 bees. So this would be the best bee for site M1. And let's say that for M3 also M7 has got the best cost. For M5, M4 has got the best cost. For M4, M10 has got the best cost. So these will be the best bees for all these selected elite and non-elite sites. Now we will update the best B for each iteration. So here on the left is the cost from previous iteration, and on my left is the cost in this current iteration, or we can say the next iteration. We will only update the P in case if it has got a better cost than the previous iteration. For example, for site E1, the previous cost was 9.88, but now the best cost is 9.65, which is clearly better than the previous cost. So yes, this B will be updated, or we can say the B for site E1 will be updated. But for E2, the best cost from previous iteration was 10.42, but in this current iteration, the best cost is found to be 14.23, which is clearly not better than 10.42. So we will not update this. We will keep this 10.42 as the best cost and the B giving the best cost as the B for site E2. Similarly, for site E3, we have previous value as 11.69 and the current value as 11.75. So this also would not be updated. But for site E4, previous value is 12.23, but current value is 12.01. So we will update this. Similarly, for M1, it won't update. For M2, it will update. For M3 also, we will update. For M4 and M5, we won't update. And for M6, yes, it is less than 17.32, so we will update. So after updating these B's according to the cost, whether we have found a better cost than the previous iteration or not, we will get 10 B's. Remember, I told previously that 40 scout bees was sent and 40 is the actual population that we are considering. These 20 bees that were sent to each of the elite sites and 15 bees sent to each of the non-selected sites are not the part of that 40 population. Rather, the best bee found from each of the elite sites after updating. Remember that I told you that 40 is our actual population. At the start, we sent 40 scout bees to 40 different locations. So 40 is our actual population. These 20 bees sent to each of the elite sites and 15 bees sent to each of the non-elite sites are not a part of that population of 40 bees. That population of 40 bees is divided such that 30 bees are sent to random directions and the 10 bees are the best bees found from the selected elite and not elite sites. So these all the bees that we have sent to different selected elite and non-elite sites, they do not form the part of that population of 40 bees. They are not the part of that population. Rather, the best bee among them is chosen for each of the site and the 10 bees from these 10 sites form the 10 bees of that population of 40, and the remaining 30 bees come from the random location because they were not selected. So in the next iteration they were sent in random direction. In this way we make up the population of 40 bees, 10 from the selected sites and 30 from the random sites. So I hope this part is clear, and at the end of each iteration we will update the best bees, the best sites, the best elite and best non-elite sites. Say for example, let's say that of the bees sent to the random location, we found a position or we found a site which is better than even the any of the selected elite sites. So this would come into selected site, and remember that at the end of each iteration we will update the selected sites, elite sites and non-elite sites, because there may be cases when these sent to the random sites may find a site which is even better than the elite or non-elite sites. So we will have to update after each iteration. What I mean by that is, suppose that these 10 bees, these 10 best bees form a part, these 10 best bees from the 10 best sites, previously 10 best sites, form a part of these 10 population, and among these 30 sites which were sent to the random locations, let's say that we find a few sites which are even better than these sites. So among these 30 sites, let's say that we find, so among these 30 bees sent to the random locations, let's say that they find sites which may be better than these 10 selected sites. So in the next iteration, let's say that the best bee